Hello everyone, this is a submission for the Texas Instruments UT Dallas competition on Hackster.io, which is at ti.com/DIY. This particular video for this submission is just an introduction video to the project and the robot and how it works. The next video will show you guys how the robot is able to solve this line maze and remember the shortest path through the line maze so that if you put it back in the same spot and tell it to show you the solution, it'll show you the shortest path to get to the treasure, which is right over there. It's the 3 black lines separated by white spaces. So this robot is the Texas Instruments RSLK Maze Edition Basic Kit. And we built it and programmed it as part of a class that I have just finished at UT Dallas this semester. And the goal of the robot in the class was to have it solve a line maze such as this one, and to show different things with the LEDs that are sitting on top of it here, the 2 red LEDs and the 1 green LED. In addition to doing that, I have also programmed the robot so that it can remember the shortest path to solve a maze, and it can show you the shortest path after it has solved the maze. That was not a part of the class requirement. So looking at the hardware of the robot, this red board here is a Texas Instruments launch pad with an MSP432 microcontroller. You can even see it has a rocket ship there because it is a launch pad. The black board down here is used for powering the motors, which is this white thing under this piece of tape. That is a motor for this wheel, and there's one other motor for the other wheel on the other side. At the front of the robot, we have bumper switches, so we can know if the robot has hit anything. Underneath the robot are 8 line sensors. These are used to determine if the robot is sitting on top of a black piece of paper or a white piece of paper, which you can imagine would be pretty useful information when you are trying to solve a line maze that is black and white. On the top of the robot, we have the 3 LEDs that I mentioned before. The green LED was not included in the kit, but it was donated for this kit, so we could use it for the class. The left LED up here flashes anytime the robot turns left, the right one flashes when it turns right, and the green one flashes in other situations, which I will explain the LEDs in more detail later in this video. At the front of the robot, we have googly eyes, which I think add quite a bit of humor to the robot. It makes it look like it's smiling. These were not included in the kit, so if you decide to buy this kit, you will have to buy your own googly eyes if you want those as well. And I believe that's everything for the hardware for the robot, so now let's move on to how it works. So I have programmed it using Code Composer Studio, specifically version 8. And the way that the robot works is, say you place it over here, it'll solve the line maze all the way to get to the treasure. The first time you put it there and tell it to solve the line maze, telling it that it's a new maze, it'll follow a left-hand bias rule. So it'll come down this line, it'll see this intersection, and it'll turn left. And then it'll turn around, and it'll turn left again, because it always has a left-hand bias. And as it's solving the line maze for the first time, as it does a left, a U-turn, and a left, it reads the LUL, which is left, U-turn, left, as, oh, I should not have turned left, I should have just gone straight. So it'll remember next time I should go straight at this intersection, and that is how it remembers the way to get to the treasure using the shortest path. So if the robot's currently here, then it has the option of turning right at this intersection, but it will not because it follows a left-hand rule. So it'll continue going straight, always taking the leftmost path it can, then it'll turn left, and it'll turn right, and it'll get to the treasure. Then if you put it back, it'll follow the shortest path, which means that it goes straight here. It does not go left, even though it's left-hand biased. Then it'll go straight here, and it'll zigzag and get to the treasure. And that's how you solve this maze from the easy location. There is a hard location, which is right on this vertical line here, facing that way. That if you put it there following a left-hand bias, it'll go on every single line in this line maze, and it has no problem solving the line maze, even though it's starting in the middle of the maze if you put it there instead of here or one of the edges. As I mentioned before, the 3 LEDs that are on top of the robot serve different functions that were required as part of the class assignment. The left LED, as I also mentioned before, flashes anytime the robot turns left. That means if it's coming here and it's at an intersection and turns left, it'll flash. However, it flashes at 0.5 hertz, which means that it turns so fast that the LED is not flash. It just simply turns on. It'll also flash if it's coming here and turning left here. Even though it's not an intersection, it will still flash because it is turning left. The right LED is the same, but for turning right. The green LED will turn on, not flash, but turn on, if it's going down something and it hits something. As soon as it hits the object, such as a calculus textbook, it'll turn on the green LED, back up, turn around, turn off the green LED, and continue on its merry way. Then, the last time the LEDs are used is when it finds the treasure. If it finds the treasure, the 3 LEDs will flash 5 times to show that it has found the treasure. So that's everything that there is to say about the robot. In the next video, I'll show you the robot solving the maze, once an easy way, once a hard way, and I'll also show that it remembers how to solve the maze using the shortest path.